Okay, so now we are finally moving on to integration, which is also known as antiderivatives. And I want you to write down that you go opposite of what you did for derivatives. So we're going to look at a derivative and then try to backtrack our answer. So I want you to write down example 1, y prime equals 2. So this is like we already found the derivative. So think back in your head, how did we find the derivative? We took our power and we moved it down and we decreased it, right? So if I'm going the opposite way, I need to increase it. So y equals, I'm going to have x there. And I'm going to increase, put that number in front. So let's see, if I took the derivative of that, bring my power down, 2, decrease it. Yes, that would be it. But here's the kicker. On integrals, on integration, on antiderivatives, you have to tack on plus c. Why? Okay, this is just random number. It can be any random number, because if I have y equals 2x plus 5, what's my derivative? 2x. What if I had y equals 2x minus 1/2? My derivative would be y equals 2x. So you have to account for, no it wouldn't. No it wouldn't. It'd be y equals 2. Y equals 2. It's all the same answer, and so you have to account for having any constant. Okay, so c does mean random number. That's a constant. We know that. So you have to account for having a constant. You could say y equals 2x plus 5,001. Well, my derivative is still going to be y equals 2. Okay. So that is pretty much integration right there. The basics of it, you're just going the opposite direction. I'm going to keep doing this video. So we write an integration like this. It's like an S, but really tall and skinny. And so if we have find the they're gonna say the antiderivative. So like the antiderivative of 3x. Okay, so actually I am gonna start it. No, I'm not. So the antiderivative of 3x dx. What does this mean? This just means with respect to x. It's going to be there. Get used to it. It is going to be there. Okay, so the book is going to tell you to rewrite this as 3 and then only look at the x dx. That just means with respect. That's fine. We're going to increase this power by 1. So there is a 1 there. So you have to increase the power, so I have x squared. And I have to put it on bottom as well. Tack on my constant. So they tell you to, when you get larger numbers, you may want to pull it out front, but I'm not really caring about that. 3 has x squared. I think it's just an extra step that you have to do right there. But that is my answer. So this is our antiderivative. Okay, so let's go back and check it. Say we had y equals 3x squared over 2, and let's say plus 5. What would be our derivative? Well, we would put it out front, and then that 2 and that 2 are going to cancel, so we'd have 3, and we decreased it plus 0. Is that what we started with? Yes, it is. It is. Okay, so it's just going the opposite direction. Let's do another one. So we'll call this A. We have it, the directions say rewrite the, like, integrate. Okay, and you have 1 over x cubed dx. Again, the dx, you're going to have that. So if I'm wanting to integrate this, do I ever like an exponent on bottom? Technically, yes, if it's my final answer, but I don't like to see it that way. So I'm going to rewrite this as we're taking the integral of x to the negative 3rd power. Okay, so if I want to increase that, you get rid of the integration sign when you actually do the deed. So if I increase this by 1, that is going to be x to the negative 2, because negative 3 plus 1 is negative 2. I have to stick that on bottom. And what else do I have to account for? c. Now, again, I'm going to clean this up, and so I'm going to get, like, -1/2x² plus c, because that's just a cleaner final answer. I'm going to go ahead and stop this video and get a new piece of scratch paper, okay?